Così comincio io.
Per vedere meglio se...
No, non importa, tanto basta che vediamo i LED che blinkano.
Ah, ok.
Okay.
So okay, we're about to start again another talk, and this time we're Davide Corio and Alessandro Pasotti are going to talk about Python and Arduino. So let's give them a hand.
Thank you. Welcome, everybody. I'm so glad that the room is so full. This demonstrates your interest in this topic. I can read his mind, and he's asking why this guy is dressed this way. Well, I'm a businessman, so what I mostly care about in my business is time and money. And you know, Python is something we can describe as a very business-friendly environment. Because when you develop, when you do debugging, when you make your own prototypes and so on, you save a lot of time with Python. The same is with Arduino. With Arduino, you can save a lot of time and a lot of money when you have to prototype, when you have to make hardware devices. And this is the topic. Probably you know that Google is about to deliver, to publish his new Android device development kit, which is built on top of Arduino. Why they did that? Because they know that if you're going to create a prototype, you probably won't care about the specifications of your devices. Maybe you're just trying to discover if things can work or not. So you probably want things to be quick and cheap. That's the way Arduino works. It's easy to use and is cheap. So I'll just want to describe the project, the history of Arduino. So I'll try to speak about its history. On the top, you can see a nice face. This is the guy who designed Arduino in 2005. At that time, this guy was working for the Interaction Design Institute in Ivrea, which is a town in the north of Italy, in the same region me and Alessandro come from. We are proud of it. This guy was used to have some drink, to relax in a bar in this town, and the name of this bar was Arduino. Arduino is also the name of the very first Italian king in about year 1000, maybe 1002. So after this brief explanation about the story of Arduino, I would like to give the word to Alessandro, who is going to discuss with you about some maybe a bit more philosophical about the history of Arduino, about the reasons why Arduino is becoming so famous. Just a few words about the the Interaction Design Institute I mentioned before, you have to know that in this institute, these guys study how to become a sort of artist. Maybe you know that maybe you already saw in internet, on YouTube, videos about Arduino where these guys make light effects, persistence of vision, and you know, this kind of very funny things. So this is the way we usually talk about a device from the artist to the artist. Alessandro.
Thank you, Davide. Good morning to everybody. I'm not a businessman, you can see. I'm just a normal guy who likes to play with these toys. And we wanted to start from the very, very beginning. This is an ancient calculator, which you can touch and manipulate with your hands. And this is one of the key topics of today. And with the digital revolution brought to us by the information technology industry, we assisted to a progressive separation between the calculation itself and the reality. The very same happened into the software industry itself. The two main branches, software and hardware, were initially a single industry, but they divided, and now they are separated into different branches, and software is much more important probably. We saw also recently a kind of row of acquisitions by software companies. Think about Oracle and Sun Microsystems, or Google and Motorola, and who knows, maybe Microsoft and Nokia. Tomorrow maybe. Okay, so what the human beings are very good to do is to manipulate objects with their hands. At least this is what we have done during the last 200,000 years. So in software interfaces, we have been using metaphors to reproduce the behavior that we have in the real world. We can touch things with our hands, we can move things, we can place things in places, and so on. And one of the most famous metaphors is, of course, the desktop itself. And but also we have the trash bins where we can put files which we want to delete, or the file system itself is shaped like a tree. A tree is a structure that we know very well, of course. But we probably gone too far with this, because abstraction, of course, is necessary, is a reaction to complexity. But maybe we've gone too far in some cases, like, for example, for the virtualization of hardware into software. You know, software is expensive, it occupies a place, it becomes obsolete very quickly. People, I think, is scared about hardware, and companies too. So this is one of the reasons, because the industry tried to use software interfaces that are very similar to real objects. In a few cases, especially in the late 90s, we saw some software interfaces that, of course, they look familiar to the initial users. I don't know if you can see it. No, it's a little bit dark, but anyway, this is like an amplifier or something like that, and you had to rotate the knobs with a mouse, which was almost impossible to do. And but you saw a lot of this kind of interfaces during the last 20 years or so, I think, like also phone interfaces or something like that. And at the end of the story, it's all about interactivity. So the way we interact with machines and the way the machines interact with the environment. And this is one field in which we probably didn't see so much evolution. If you think, you probably interact with your computers mainly with a keyboard and a pointing device of some kind, but nothing more. And the output is even less. It's just a monitor and maybe a sound, but for notification, nothing more. So this is a field in which we probably have a lot of things to do yet. And here is where it comes Arduino and the design of new devices which can interact with the environment, with the analog environment, and interact with the digital machine with this kind of environment. Okay, now it's to you, Davide.
I'll be quick. We all are curious. We all behave like kids when we can disassemble things. We can do this with software, thanks to the free software, but it's a way more hard to do that with the hardware, because we probably don't have specifications, we don't have the sketch of the hardware, and maybe if we disassemble a printer, maybe we cannot assemble it again. This is what is changing with open hardware, because when we play with something like Arduino, we can disassemble it, we can learn how to make it by our own. You can do it yourself at home by a few very cheap components. But this is something extraordinary. We are used to dig inside our software, we can debug it, and now we can do the same with the hardware. This is why Arduino is so powerful, why it's so important, why we are here. So now we can start to talk about something more technical. I'm leaving the word to Alessandro again, because he knows these things better than me.
Okay, this slide is just to introduce the concept of physical computing. Physical computing is a way to solve the problem of, to have a better interaction with the machines. It's a way to build physical interactive systems which can, through software and hardware, can sense the real world and can interact with the real world through sensors and actuators. And this is was made possible by the diffusion of low-cost microcontroller units, which are almost everywhere in every single electronic device. I have probably one here inside too. And these are very, very cheap now. And like the most electronic components are available for a very low price. But the key, the most important thing is that we have an easy access to the technology and to the knowledge we need to make these things work. And this is thanks to the open source community and to the internet and to the diffusion and the share of knowledge that make this possible. Okay, Davide.
Just a few words about something we already tried before. Why Arduino is so important. As I said before, can you hear me? Can you hear me now? Okay, good. As I said before, Arduino is cheap, is easy to use, because you can find a lot of documentation, so you can find sketches and so on. But moreover, is easy to use because you have a software, an EDE software we are going to discover. Then we are proud it's made in Italy. But one of the most important thing is that the project is doing marketing. This is what you get when you buy an Arduino Uno model. Oh, this is marketing, because you get a nice box, you get stickers, you get some instruction here, and of course the Arduino card. But what's inside this box? As you can see, you get hardware, because you get Arduino. In this hardware, you get software, because you get also a bootloader. A bootloader is useful because without it, you need to use a programmer to upload your software to the microcontroller. This is very important, because if you try to assemble Arduino by your own, you'll have to use an external device to upload your sketches. Then you get libraries. If you need to interact with a sensor, with a temperature sensor, for example, you probably need a library to interact with this sensor. Arduino provides a lot of libraries. This can easy a lot of life. Then again, you get an IDE, you get a software with you can build your software, you can program your software, you can upload the sketches to Arduino without an external proprietary software and external devices like the programmers. Then, much more important, you get a community. You get something you can talk with. You get forums, mailing lists, IRC channels, and then you get manuals and examples. You can buy other hardware. So you can buy the same thing with from competitors, but you probably have to pay for the documentation, pay for the IDE, pay for the libraries. This is what I think Arduino is so important. Okay, now let's get into something more funny, I would say. So
more technical. Okay, this is just to give you an overview of the board. You have on the left side a USB connector. You can plug directly to your computer and have the power supply from the USB and the serial communication from the USB. So you can upload your programs using the cable, and you can communicate with the board using the USB. On the lower side, you have an external power supply connector. If you want, you can use it standalone, not connected to any computer, and just give the power supply through this plug. And on the top left, you have a reset button. It's just a push button. You push it, and the boards get reset. And we have two rows of, I'm sorry, don't have a stick. Okay, on the top, you see the row of pins. There is a row of pins, and on the lower side too, we have two different rows here. This is the power supply mainly, and those are pins connected to the microcontroller. We have two microcontrollers on this board. The main one is the big one. This one is you can unplug it and put it in another place, or change, or replace, and so on. And there is another one, very small, soldered directly onto the board. And this is just dedicated to the conversion of signals from the USB to the serial connectors. So it's USB to serial, and stop. And then we have a couple of components which are dedicated to the power supply, to the voltage regulation, and the quartz here, which gives a 16 megahertz signal, clock signal, to the microcontroller. Please. Okay, this is a slide. These are the details of the brain of the board, which is the microcontroller. It's produced by Atmel, an American company, and the model is Mega 328. And we have 2 kilobytes of RAM, 32 of ROM, 1 kilobyte of EEPROM, and 14 digital pins. You can see the pins there. And 6 of those are capable of generating a square wave, which is called pulse width modulation. This is the system through which the square wave is generated, of course. And we have 6 analog inputs with an analog comparator, which translates values from voltage to digital values, but we will see it later. It can run up to 16 megahertz, and we can program it in assembly, or better in C or C++, using a modified version of the new C compiler. So this is one of the most important things of this microcontroller unit. To give you a rough idea of the computational power of this device, here we have the Mega 328, and here is an old IBM 802286. Of course, the weight and the cost is very different, because this was the state of the art in the 80s, and it costed a lot of money at that time. So it's quite powerful yet, even if it's small. Okay, splitting the byte, because these devices are 8-bit RISC devices. And how do we program them? We basically set individual bits of an 8-bit register. We have 3 different ports, which are called port D, you can see in different colors, port B and port C, which are dedicated to groups of 8 pins each. And you can set individually the status of those pins, just changing 1 bit. and setting 1 bit or clearing 1 bit in those 8-bit registers. So this is basically how it works. The pins are, we have 2 groups of pins, digital and analog. The digital pins are basically an electronic switch. They can be on and off. When they're on, they have a voltage of 5 volts because this board works at 5 volts. And when they are off, they are 0, so grounded. And they can be input or output, of course, so they can read values and write values, let's say. And the analog pins here are dedicated to input. So they have a 10-bit resolution analog comparator, so they can read voltage values from sensors and translate them into digital values with a 10-bit resolution, so 124 values. Okay, this is how pulse width modulation works. It's basically a square wave generated by pulses of signals, and the shape of the wave can vary between a 0, which is the same that having a digital pin to the low level or logical 0, to logical level 1, which is 5 volts tension continuous. We have 255 levels in between. So we can simulate an analog signal using this system with a digital device. This is the way we simulate an analog signal, which varies between 0 and 5 volts. Okay, how do we program these boards? This is using C, the C programming language, without any Arduino library. So this is the standard way to program this kind of chips. And you just use the standard header provided by the compiler. And it's quite complicated. You consider there is a lot of bit-wise operators, so left shift, right shift, and Boolean operators to set or clear the bits. It's not really handy, it's error-prone, and it's difficult to read. So this is why Arduino gives us the possibility to write programs. This is the same program of I showed you before. It was a program to blink a LED connected on pin 13, and the same sketch, the same program. Here is just five lines plus the function wrappers, and you can see it's really easy because you just set pin mode. Pin mode it means the mode of that pin 13 is output, so we use it for output. And the first function setup is just run once. When you give power to the board, it runs just once. Then you have a loop, which is just wrapped into the main of the C program and runs forever. Then you have digital write, a delay. In digital write, you can set high or low the pin. So when the pin is low, it's off. The LED is off. When the pin is high, the LED is on. It's not really difficult. This is probably the most important new brought to us by Arduino, because using the libraries, using the IDE, we have very handy functions ready to use. We don't have to worry about manipulating single bits of registers, and there are a lot of checks and controls. Of course, the drawback is the speed. If you want to do something really fast, you should use directly the bit manipulation, the register manipulation, because function calls in this kind of device are really, really slow. This is what I've experienced directly. And so sometimes you have to prototype using these Arduino libraries. Then if you want to have something that works at a certain speed, you must rewrite the function using directly the registers manipulations. Of course, Arduino is, as Davide said before, it's not just a board, it's an ecosystem. It's a lot of different kind of boards and expansion boards. We have basically sensors and actuators. Sensors can read values from the outside world. Actuators can change the world by light, sound, or radio frequencies, or motors which can move things in the real world. Here we have a couple of examples. On the left side, we have another kind. This is another official Arduino board. It is Arduino Mega. It runs with another chip, which is much more powerful. The problem with that chip is that it's tiny. It has tiny pins, so it's soldered directly onto the board. You cannot remove or replace it. It's not very useful if you want to do something with a do-it-yourself project. You just have to buy the board, and you cannot build easily that board by yourself. And this is another kind of board. This is very small. It's like a coin of €2 or something more. And it's powered by 3.3 volts, so it consumes less power. And it's very used in wearable computing. So you can sew that chip on your fabric, and with tiny thin ropes, conductive ropes, build something, so placing LEDs on the fabric and doing very funny things. On the right side, we have the expansion boards. They are called shields. Shields because they plug one onto each other. You can create a stack of shields because they have a standard layout, of course, pin layout. In the middle, you can see the Ethernet shield, which gives Arduino Ethernet capabilities. It also has an SD connector. And there are hundreds of clones of different kinds of Arduinos, and I would say several hundreds of different expansion boards. This is what makes Arduino unique in this field. Okay, you can build an Arduino by yourself. It's not difficult, really. And you just need a couple of components. You can see probably 10, 11 components, and they are all quite common. The most expensive one is the microcontroller itself. In small quantities, it's about €4 on eBay. So for less than €10 and a bit of soldering, you can build an Arduino by yourself. You don't need to spend €26 or so. Of course, what you miss here is the conversion between USB and serial signals. So you have to unplug the chip and program it using another Arduino, for example. Or you can connect it to another Arduino because the chip on the Arduino can make the conversion for you. So if you just have one Arduino, you can build a lot of Arduino by yourself. And this is just what I normally do. Okay, Davide, it's your turn again. We are approaching Python at the end.
Yeah. As I said before, I'm a businessman. I'm not a developer, but I really like to play with Python and Arduino, so please let me do this. The simplest way you can interact with Arduino is to send and receive text. You can do this accessing the serial port with using, for example, the PySerial module, just like this. Oops, sorry. Okay, as you can see, those are two very simple examples. On the top, you can see how you can read from the serial line. Those hello words are messages from the Arduino. On the bottom side, you can see we are writing something, a string of 5, to the serial port. So we are sending text to Arduino. We can do this live. Okay. Probably you can see the Arduino board. You can see it's not properly on focus, but you can see the LED. Okay, I can import serial. This is how Arduino is being recognized by Ubuntu in this case. Okay, we got connected. Then I can just send 1. Okay, good. Okay, yeah.
Force contact.
Demo effect. or I can turn it off. Good. Okay. As you can see, it's very easy to interact with Arduino this way, but we have to see what I put on Arduino, because we just sent a message, but inside Arduino I wrote a few lines of code that receive this text. I'm launching the Arduino IDE. I can load my sketch. Okay, here we are. As you can see, it's a very few lines of code sketch. I listen for a 1 or for a 0, and in accordance to what I receive, I can put the LED high or low. Very simple. But if you want to approach this in a more professional way, you'd better use a proper protocol, like the Firmata protocol, Alessandro.
Well, okay, the Firmata protocol is a standard protocol for microcontrollers. And you can see the website. It's available for different kind of microcontroller units. And it's a protocol based on MIDI, so the protocol used on musical instruments. So it's very compact, it has error checks and has a lot of advantages. And it allows you to control every aspect of an Arduino board. So it's also very easy to use. We have a nice package for Python, which is called PyFirmata, and it allows you to talk with an Arduino, which has preloaded the Firmata firmware, and to control the board in a very easy way. This is an example. We can just do import PyFirmata. We set a couple of constants. We are always doing the same hello world program, so blinking a LED on pin 13. And it's almost the same you've seen before, but the difference is that you can directly set every single pin, and you can also control the servo motors, and can also generate pulse width modulation signals without writing directly your code onto the Arduino board. So it's really handy to use, it's complete, and it's open source, of course. We probably have a better demo later about this. Okay, just to cite this project, it's a project to run run Python directly on an Arduino board. It is not possible to run Python directly on an Arduino Uno because it doesn't have enough RAM. The minimum required is 4 kilobytes of RAM, but it's possible to run Python, a stripped down version of Python, of course, on the Arduino Mega, the other board you've seen before, the bigger one, because it has another chip which is much more powerful. It's not much more than a proof of concept, but okay, it's interesting knowing that we can run Python directly on a microcontroller unit. Other projects, okay, they are just for reference. Here, there are other protocols based on ASCII messages, like we have seen before with BiSerial. And if you search on the web, of course, you find other projects too. Okay, now we have the final demo with fireworks and special effects.
Have to stop
Hope that it works, of course. Okay, on this other board, you see probably I switched the board. I have already preloaded the Firmata protocol. And a few weeks ago, I wrote a component for OpenERP, which showed how to control the board from the web. This add-on uses PyFirmata and the Firmata protocol, and in our example, we will hopefully show you how to control a motor to make some sound and to light a LED.
Okay. Just a second. Starting OpenEuroP. Let's check if OpenEuroP can see the board. Switch the port. Okay.
Okay, so basically we have two different tabs, one for the analog inputs and the other for the digital IOs. And you can set the different kind of output. So we have now the pulse WM enabled pin 10 with servo output is connected to the motor. You see it here? Yes, maybe. No, it's not that good, that video, but anyway. So you can interact with this form and set all the values for the individual pins. It moved. Now let's try with 180 degrees. Yes, refresh. Okay, it moved, it works. Okay, the LED is connected to pin 13, I think. So we can set, the output is okay. Perché non va? Allora facciamo un save. Okay. It worked with the save. And last thing to do is connect to pin the buzzer. Pin 3. Okay, let's try this. Output is okay. We can also try PWM later. Okay, we can also try the PWM, which gives us much control. Okay. And 255 is a maximum level. Okay, it works. Not a nice sound, but yet it works.
Okay.
Of course, you can also read analog values. You have to activate the pins, and if you have a sensor attached to the pins, you can read the values.
Okay. Thank you very much for your attention. We tried to save more time for the question because, for our experience, questions would take more time. So, thank you very much.
Hi. I think the goal is to actually build a low-cost hardware which can be used by community.
I can't hear you. I'm getting closer.
I think the goal of the initiative is to build low-cost hardware which can be used by community to build open projects. But there are also other initiatives like Raspberry Pi, and they considered using Linux kernel, which gives a lot more flexibility for developers to reuse existing tooling. Did you also consider that approach and moving to ARM processor and supporting a Linux kernel?
Well, I can answer. Okay, Raspberry Pi and Arduino Due are based on almost the same architecture, so it's an ARM based. Arduino Due is on the way, it's coming, but I think that Arduino Due and Raspberry Pi are completely different beasts as Arduino is. Why? Because they are based on very complex chips which require a lot of external components to work, and they are much more expensive, and they are completely different. You can run Linux on a Raspberry Pi. You will never run Linux on a 2 KB RAM device. So they are completely different things, in my opinion, of course. They are useful for different fields of the industry itself also.
Another question? Another one?
Well, maybe it's a bit of a trolling question, but what do you think about the Raspberry Pi?
Okay, I'll take this. My company developed an ERP system. As an ERP system, we often have to integrate to industrial machines, for example. So we often have to deal with PLC, with any sort of hardware. And in this case, you need something very easy to approach, like Arduino. When you are designing industrial machines, you probably don't need an HDMI port or sound port and so on. So this is why Alessandro was saying that Raspberry and Arduino are two very different things. You also have to consider that when you have to build by yourself a board like Arduino, obviously you'll not be buying it. You'll have to create your own board. And if you follow the sketches of Arduino, you can build a real PLC, for example. You don't need Raspberry for this kind of jobs.
Another point is the power consumption. So Raspberry Pi and other ARM devices are much more consumes much more energy than these kind of devices. This is important if you must place them in some places with a battery and just give the battery to supply the board. And
I would also add the fact that Raspberry doesn't have the same community. You can find example of sketches for Raspberry, but the community and the project is not so mature. That's the big difference from my point of view. I'm a businessman, as I said before.
And about the use you do with the ERP, is it secure enough for the industrial application? Is not the hardware too weak? Or?
Good question. Arduino is a prototyping platform. You won't use it in production. Well, you can also do that. But obviously, you can use it to test your own software in your office. It's a bit difficult to bring a big as elephant PLC or industrial machine in your office. So you need something smaller. Okay, when you're prototyping, you are not developing something you can put on production. Arduino is not isn't made for this kind of jobs.
Hi. There is some, let's say, porting of FreeRTOS or something like Tiny Real-Time OS. Have you ever tried some of these microkernel, let's say?
I'm not sure if I got your question, but we have probably not enough computing power or RAM to run any operating system on those boards.
I mean, FreeRTOS or something like this?
Research, I didn't.
Real-time operating systems.
But there's no room for any operating system of any kind. We have 2 kilobytes of RAM and 32 kilobytes of ROM.
Okay, so maybe not operating system, but that handle task or inter-process communication, something like this.
Oh, well, if you want to do something like that, you can probably take an advantage from the embedded capabilities of the chip. It has a lot of things we haven't talked about that, like, for example, watchdogs, timers, and other a lot of interrupts. It has 2 external interrupts and a lot of internal interrupts. So you can program, okay, it's used for real-time signal processing. It's possible to do that because you can interrupt the program and run another routine when you want. But we are not talking about operating systems. We are talking about directly manipulating the registers of the chip.
But I would add that we are waiting for the next Arduino board, the Due, Arduino Due, which is probably capable of running an operating system. I already saw a porting of Linux for its chip, for its processor.
I'm not sure they're working on it, but it's based on ARM, so it's a Cortex 8, A8. I'm not sure, but of course it's 32-bit processor with a lot of RAM and ROM. It's another story. It's completely another story. But you cannot use it on do-it-yourself project because it's a chip with a very tiny pins and hundreds of pins, and soldering that chip would be a real problem for an hobbyist. So it's another, I think it's a completely different device. Okay, the marketing manager probably decided Arduino would sell well, so they called Arduino Due, but it's a different story in my opinion.
Okay.
We are talking about turning on lights, start motors, and so on. That's very different things.
So we had another question.
I was wondering what products you're building and who you're selling them to.
No, okay, no, we are not involved into the Arduino project. We are not selling Arduino either. We are just using it to prototype what we do. We develop a Python-based software, so this is a tool for us. We are not involved at all into the project.
Okay, so another last question.
Okay, and so how many kinds of Arduino boards are? If someone wants just to test something, and what do you will recommend to buy?
You mean different kinds of Arduino boards?
Yeah, because
150, something like that. Yeah. So there are a lot of clones, but well, basically the Arduino Uno is the most common. It's kind of standard board. Then we have the Mega. Okay, there are 3, I think, official boards. 3 official boards, and a lot of clones. The official boards are the Arduino Uno, and there is the 2009, which is older, a little bit older. And there is the Mega, Arduino Mega, and the Tiny or Mini. I don't know which. They all use a different chip. So this is mostly the standard one. The Arduino Uno, which uses the same chip of the Arduino 2010, I think. Okay, they're not very different. This is a family of different chips, so there are many Arduino with the different brothers and sisters of this chip.
Then you can use the shields to extend the Arduino. You can find on the market shields for almost everything. You can find RFID shields, GSM fields, GPS shields, and so on. So you just need that, and you can plug shields on it. I know that some guys are working on a satellite project. They are putting Arduino into the space. That's quite fun because it's a pile of I don't know how many shields. On top of an Arduino Uno. It's amazing.
Thanks. Yeah.
Okay, so that's it. Thank you very much.
Thank you.